Hi again, this is still Unit 3 and this is solving equations with rational exponents. So this is very much like solving with radical equations, only now you're going to have to convert your rational exponents, and this just means exponents that are fractions. That's all that means. You're going to convert them into exponential, from exponential into radical form, and then solve like we did in the last video. So here's the rule that we need to remember. If you have any base raised to a fractional exponent, also known as a rational exponent, then to change that into radical form, it's going to look like this. You write the radical, the number that's in the denominator becomes the index, and then x can be raised to the m power, like so. Okay, so this is with rational exponents, and then over here this is radical form. Okay, and you can go back and forth. Sometimes I'll give you radical form, you need to put it in rational form. For this video we're going to start in rational form and we're going to convert to radical form to solve our equations. So let's practice a little bit. Let's say that we have x to the 1/2 power. Let's convert that using this rule into radical form. So that means if it's going to be radical form, I got to create a radical, and then the 2 goes in the index, and then the x is raised to the first power. So this is the same as saying the square root of x. Okay? How about another one? Let's say you have w to the 1/3 power. That's going to be a 3 as the index, and then w to the first power. So this is the same as the cube root of w. Let's say we had more than one thing. Let's say we had 2z raised to the 1/4 power. Same idea. You're going to make the radical. You're going to put the 2z underneath the radical. This 4 goes as the index. In class we say it goes in the check mark, but it is the index. And then if you want to keep parentheses, raise that to the first power. So this would be the 4th root of 2z. And then let's do one more. Let's say we have x plus 7 raised to the 2/3 power. So this one's a little bit trickier. You're going to make the radical. The 3 goes in the check mark. Put the parentheses around the x plus 7 and raise it to the 2nd power. So that is going to stay the same. There isn't really anything that'll simplify like the other ones. That is simplified for that one. So let's actually practice this with some equations. So our first example is x to the 1/2 plus 3 equals 6. So in order to do this, we should use the rule and change it to radical form, because now we know how to solve radical equations, and so we can use that skill to help us solve this type of equation. So x to the 1/2 we talked about already. That's going to be the square root of x plus 3 equals 6. So now we go back to those 4 steps that we just learned in the last video. You want to get the radical by itself, then raise both sides to the power of the index, which in this case is really a little 2, and then solve for x and check your answer. So let's get this radical all by itself. To do that, we need to subtract 3. So this becomes the square root of x equals 3. Now we're going to raise both sides to the power of the index. So I'm going to square both sides. So x equals 9. So our answer is 9. Now we're going to check it and make sure that it makes sense. You can use radical form, or in your calculator you can put exponent form in there too. Your calculator will do it either way. I'll show you how that works. So we're going to take this 9 and we're going to put it in for the x. Okay, this is going to go right there. So it'll be 9 raised to, I'm going to use alpha y equals so that I get a nice fraction. So this will be 1 over 2, and then arrow over plus 3. Hit enter, and it comes out to be 6. So that means we have a good answer. Please make sure that you always check just in case you have an extraneous solution. Let's try this example. How about m over 4 raised to the 1/2 power, and that equals 5 minus m raised to the 1/2 power. Okay, so to do this one, rewrite it in radical form. So by now, 1/2 should sound like the square root, should be getting easier. So the square root of m over 4 equals the, now
we are going to raise both sides to the power of the index. So we're going to square this side and we're going to square the other side. So now this cancels out. You have m over 4 equals 5 minus m. That cancels out. Now this is all ready for us to use algebra to get the m by itself. So I don't really care for fractions so much, so I'm going to get rid of this 4, and to do that I'm going to multiply by 4 on both sides. When I multiply by 4 on the right hand side, I will need to use the distributive property and multiply that by both terms. So this is going to go, you're going to have m equals, and then this will be 4 times 5, which is 20, minus 4 times m, which is 4m. So now we need to get the m's together. So we're going to add 4m to both sides. M plus 4m is 5m. If 5m equals 20, divide by 5. And I'm going to go over here. M equals 4. So our answer is m equals 4. Now we need to check it. Of course, always check it to make sure that it works. Put that in. I'm going to go back up to the top here. So wherever I see an M, I'm going to put a 4. Okay? Now this one we could probably do mentally. I'll put it in the calculator just to show you how that works. But I know that this one's not going to be too hard to do mentally. It'd be 4 over 4 raised to alpha y equals 1 over 2. And for that, you're going to get 1. Now we're going to put it over in the other side of the equation. So that will be 5 minus 4 raised to alpha y equals 1 over 2. And we get 1 on both sides. So this is a good answer. Okay, let's try one more. Let's say that we have something like this. X plus 7 raised to the 1/3 power plus 5 equals, also equals 7. How about that? So now we need to change this into radical form. So this would be the cube root of x plus 7 plus 5 equals 7. We need to get the radical all by itself, so we're going to subtract 5 from both sides. That goes. Cube root of x plus 7 equals 2. Now we're going to cube both sides. That goes. X plus 7 equals 8. Subtract 7 from both sides. X equals 1. So now we're going to plug it in.
I'm going to plug it into the left-hand side. 1 plus 7 raised to the 1/3 plus 5, and that equals 7. That's good, so we've got a good answer. I just thought of one more thing that we should go over. Let's try just one more example, and then you can try your practice work. Now let's say we had something like this. 2x plus 3 raised to the 2/3. And let's add 4, and let's make that be equal to something that's not too terrible. How about 5? Okay, keep it really basic. I just want you to go through the process more than anything. So we want to change this into radical form. All right, well, this is going to be the cube root. The 3 is going to go in the check mark of 2x plus 3 squared. The 2 is going to go here. Plus 4 equals 5. So we want to get the radical all by itself. So we're going to subtract 4 from both sides. That goes. So you're going to have the cube root of 2x plus 3 squared equals 1. Now, we want to get rid of the cube root first. This is on the outside, so we deal with this first, then we'll deal with this part. So we're going to raise both sides to the 3rd power. That's going to go away. You're going to be left with 2x plus 3 squared equals 1 cubed is 1. Now, you're going to take away the squared part. So now, the opposite of squaring something is going to be a square root. You're going to square root both sides. So this is going to go away. You're going to have 2x plus 3 equals 1. Okay, now we're going to assume the principal root for this example. So we're just going to take the square root and make it be a positive 1. And now subtract 3 from both sides. So 2x equals 1 minus 3, which is negative 2. And then divide by 2 on both sides. X equals negative 1. Okay? Now this was definitely a harder example. If you need to pause the video anytime, please do and catch up so that you can think about the steps. I'm going to check the answer now. So I'm going to put it into my calculator. 2 times negative 1 plus 3. Close my parentheses. Thankfully, my calculator can do order of operations, so I don't have to worry about multiple parentheses. Alpha y equals, oops, nope, that's not the way I want it. Let's try that again. Parentheses, 2 times negative 1 plus 3. Close the parentheses, raised to, that was the part I forgot before, alpha y equals 2 over 3. Putting it into the original equation, and I'm plugging in negative 1 wherever there's an x. Plus 4. And my answer is 5. So that works. Try your practice problems, and if you have any questions, please feel free to ask.